All right, let's go ahead and start our third example of using the elimination method to solve a system of equations. We can see, again, these are in standard form, so elimination is likely the best choice, and that we've already written them so the x's are stacked and the y's are stacked. So we're ready to start with step 2, which is comparing the coefficients. Right away, I can see that I've got a match here with the x's. 3x and 3x. If I check the y's, I can see I don't have a match, -2 and 1. So it's the x's we're going to eliminate. Step 3, we compare the signs on those matching coefficients. In this case, they are the same sign, so we're going to need to subtract in order to eliminate the x's. This example is going to look a little bit different than the last few. When you subtract, you are subtracting the entire bottom equation from the top equation. That means that subtraction applies to the first term, the second term, the constant term. Everything's being subtracted. So let's go ahead and do that from left to right together. I know that 3x minus 3x is 0. Those things cancel. My next operation is -2y minus another y. That's going to give me -3y. On the other side, I have -2 minus 10, which is going to give me -12. We're on to step 4, which is the solving process. Same as before, we're going to divide out that coefficient, divide both sides by -3. On the left, they cancel. So that's going to leave us with y equals negative divided by negative is positive, and 12 divided by 3 is 4. Last step is to substitute that answer we just found, y equals 4, into one of our original equations. I'm lazy, so I'm going to pull over that first equation. 3x minus 2y equals -2. And then I'm going to rewrite it with a placeholder for y, because I'm going to make a substitution for that variable. So 3x minus 2, and then a placeholder for the variable I'm substituting, equals -2. And then I'm going to make that substitution. Y becomes 4. Next, we simplify. We do that multiplication. 2 times 4 is going to give me 8 equals -2. And now we can start the solution process. First, we deal with the constant. To undo subtraction, we're going to add 8 to both sides. That eliminates the 8. On the left, that means the only thing we have left is that 3x. On the right, -2 plus 8. When those signs are opposite, we subtract. The difference is 6. And because the bigger number is positive, it's a positive 6. Last step is to divide out that coefficient. So divide both sides by 3. The 3's are going to cancel, and that's going to leave us with x equals 2. So our final solution, written in ordered pair form, is going to be 2, 4. And just like example 1, I'm going to pull up GeoGebra and graph those just to be sure. Subtraction can be tricky, and we want to make sure that we did it correctly. So let's go ahead and pull up GeoGebra. And you can see it kind of pops up there. And we just type our original equations in. So 3x minus 2y equals, -2. And 3x plus y equals 10. So we can see our blue and green lines here. If I click on that point of intersection, we get 2, 4. So GeoGebra does in fact match the solution that we found, so we know we did that subtraction correctly. Okay, we have, I think, 3 more examples. They're going to get progressively more complicated. The last 2 are going to show us how that multiplication process works in step 2. So I will see you in our next example.